Okay, so now we have our Wi-Fi card in monitor mode. We can sniff all the packets that are within our Wi-Fi range, even though they're not directed to our device, and even without connecting to any network, even without knowing the password or username to the network. So what tool we're going to use? We're going to use a tool called Airodump-ng. It's part of the AirCrack suite. It's a packet sniffer, allows us to capture all the packets around us. We can run it against all the networks around us, so we'll collect any packet that are within our Wi-Fi range, or we can run it against a certain AP or access point, so we'll only be collecting packets that are coming from a certain Wi-Fi network. We'll see how we run the program first. First, you need your Wi-Fi card in monitor mode. I have it now in monitor mode, and the name of the Wi-Fi card in monitor mode, it's 110. So we'll just clear this, and we will run Airodump-ng and 10. It's just as simple as that. 10 is the name of the Wi-Fi card that has monitor mode enabled on it. And now you can see it's starting to list all the networks around us. Another use of Airodump-ng is to identify all the networks around us and to identify all the connected devices to these networks. So I'm just gonna Control C now to stop sniffing, and we'll just have a quick look now. All the packets that we sniffed, now we didn't save them anywhere, so there was really no point of analyzing the packets, because we just ran it against all the access points around us to see what networks are around us and what they and gather information about these networks. So you can see like there is quite a good bit of networks around me. The BSS ID is the MAC address for the access point. So each as we said, each network device has a MAC address, and it's here written under the BSS ID column. The PWR is the power, so it's how far is the access point from our Wi-Fi card. You can see the test IP, this is the AP, this is the test router that we will be running a few attacks against. It's here in my room, so it's very close to me. It's -34. You can see as you go down, the networks are further and further away from me. So the closest the network, the easier for you to get to sniff the packets, because obviously you're closer and the packets can be collected easier. Also, all the attacks that we're going to explain in the future, the closer the network to you, the more effective the attack, and the quicker you will gain your access or achieve your goal. Beacons is the signals that the AP send. So each access point send a certain type of packets to tell all the clients around it that I exist and I'm there. So even if the network was hidden, it will still send these beacons to tell everyone around that network is, I'm here, I'm an AP, I have my BSS ID to be this, and I'm running on this information. So this is the number of beacons that each access point is sending. The data is the number of useful packets that we have sniffed. We'll talk about this later when we start talking about decrypting web encryption. So we'll just leave this for now. S is the number of data packets that we have collected in the past 10 seconds. So as you can see, we have 0 here, so 0 data packets in the past 10 seconds. Channel is the number of channel that the access point is broadcasting on. So each access point broadcasts on a certain channel. This is used so that there is no interference between access points that are beside each other. So say for example, I have an access point here, and like 5 meters from me there's another access point. If both of them are running on the same channel, there will be interference between those two access points, and the signal between them will be shorter, so the range of those access points will be shorter. So we use different channels so that there's no interference between the packets that are sent in the air. MB is the maximum speed supported by this access point, so it can go up to 54. Ink is the encryption that's used in that access point. So we see the encryption here is WIP, here is WPA2, here is WIP again, we have WPA here. And if it's an open network, you'll see OPN here in the encryption. Cipher is the cipher that's used to decrypt the packets. So for WIP, it's WIP. But for WPA2, it can be CCMP, it could be TKIP. We'll talk about these later when we get into WPA cracking. Auth is the type of authentication that's required for this access point. So we have PSK, pre-shared key here. We have MGT for this one. And we'll talk about this later as well when we go to WPA cracking.